Good morning, good afternoon, good evening from where and you are the world. So today I'm going to speak about leveraging GitHub Action for DevSecOps. Before going to the slide, the small introduction about me. My name is Joshua Jebaraj. I work as the associate security researcher at the company called B45. I'm also the author of the project of GCP code. My primary area of interest is around cloud and cloud native security and DevSecOps. I regularly share my learnings via blogs or project at my website or at my Twitter handle. Feel free to reach out to me if you want to discuss anything related about security or just have a casual chat. Before going to the actual topic, let's understand what is CA and CD. CA stands for continuous integration. It is the process where the developer continuously integrate the code into the source code repository. The source code repository can be anything like GitHub, GitLab, or self-hosted Git services. In this phase, the developer will be continuously integrated the code. Once the code is integrated, the unit test and the automated test is performed. Most of the tests are automated, so that the developer just need to push the code. Once the test is done, in this CA space, what we are essentially doing is we are checking whether the developer introduced any code or features that doesn't produce any error. Once CA is done, next we will move into the CD space. In the CD phase, there are a couple of things. First one is continuous delivery, and second one is continuous deployment. Let's see about continuous delivery. In continuous delivery phase, the application is deployed into the testing environment, and that test is done. Based on the test result, the application will be moved into the production or move back into the dev environment. If the application doesn't have any bugs or errors, it will be moved into the production. If the application has any errors or bugs, it will be again rolled back into the developer environment and the fix has to be made. Once fix has been made, then again it will be moved into the testing environment. Again the application is retested, then it will be deployed into the production environment. Continuous deployment is similar to the continuous delivery. The main difference between the continuous deployment and the continuous delivery is whether the human is responsible for deploying the application in the production. For example, in continuous delivery, once it is tested in the testing environment, the human has to be manually deploy the application into the production environment. Where in the continuous deployment, there is no need of humans. We can directly deploy the application using the automated process. There are many CA/CD services like Travis CA, Circle CA, Jenkins, and other services also there. But in this session, we are going to see only about GitHub Actions. So GitHub Action is the CA/CD services provided by the GitHub. It's came around like 2019. It's become popular now. Many companies started around using GitHub Action to implement CA/CD in their environment. Let's see why GitHub Action is required. So it is easy for them to get started. Many organizations are already using GitHub as the source code repository. So it is easy for them to get started without installing any third-party tools or introducing the new tool to the ecosystem. The other thing that GitHub Action provides is free time. For every month, GitHub provides 500 MB of storage and 2000 minutes of runtime for free. So anyone who wants to get started with GitHub Action, there is no need to pay anything, and it is easy to learn. All of the GitHub Actions are written in YAML, so anyone who can read and write a GitHub Action can easily get started with GitHub Actions. Writing the GitHub Action. Every CI/CD is written as the GitHub Action. For writing the GitHub Action, there are a couple of ways. The first one is writing from scratch. In this method, we will write everything from the scratch. For example, if we want to push the Docker image to the Docker hub, we will write the step for first installing the Docker, updating the package manager, then install the Docker on the GitHub runner, then build the image using the Docker, then log in into the container registry, then later push into the Docker container registry. This is not the efficient way because like we are also rewrite everything from the scratch. In order to solve this one, there is one efficient way. We can use the pre-existing action. So the pre-existing action are shared by the community, which we can reuse in our own actions. If you are from the program background, you could think like a pre-existing action as something as a library that we are going to use in our code. In the last slide, we have seen there are some pre-existing actions. So the marketplace is the place where we can see the uh, uh, place where the GitHub actions that are stored. There are many useful actions that are shared by the community and also shared by the companies that are companies. See, you can think it like similar to Docker Up, where the Docker images are stored. So it's similar to GitHub actions. In this place, the GitHub action are stored. So one thing that you want to keep in mind before using the GitHub actions is all the actions that is not secure. We should audit the actions before using in our code. Event trigger. So the event trigger decides when the action should be run. GitHub currently support there are 28 event triggers. The common example would be if you want to run the action when there is a push or when there is a pull request. GitHub also supports branch-based event trigger. For example, for long-running jobs like a DAST scanning, it is not wise to run for every push and every pull request. In that case, we can specify like only on certain branch. For example, only on testing branch, if the code is pushed, then the DAST scan has to be done. Or only on the production branch, the application is pulled, then we have to run the GitHub action. So one of the other main different main feature of the event trigger is GitHub action also support the cron job. You can specify like for every 24 hours I have to run certain actions, or for every 2 a.m. at midnight I have to run certain action. You can also specify through this using the GitHub action. One of GitHub Secret. One of the main feature of the main advantage of using GitHub action is GitHub allows to natively to store the GitHub secret, which we can use leverage in the GitHub actions. For example, if there is an action which helps to push the Docker image to the Docker registry, we have need to like couple of things. One is the Docker username, and other one is the password. What we can essentially do is we can store in the secret of the repository and use that in the GitHub action natively. There is no need of additional third-party tools for storing the secrets. In order to create the GitHub action, we have to create the .github folder in the repository where we want to create the GitHub action. Under this one, we have to also create the workflows folder. Under this one, we have to create the YAML folder where we will return the GitHub action. We will see the example hello world GitHub action. So this is the hello world GitHub action. Anyone who is familiar with YAML can easily read this one. There is no need to learn another new things and all. So I'll explain what is this hello world actions. So in this action, I am naming the GitHub action. I am naming the work action as GitHub action. I am telling the event trigger on push event just run this GitHub action. I am also specifying this action to be run on the Ubuntu based machine, and I am on the machine. These are the steps that to be run. You can basically think it of this run command as like running the same command on terminal. So this will print out like the job was automatically triggered by GitHub.event name. So GitHub action by default has some of the environmental variable that is already present. In this case, the GitHub.event name will be replaced by push, since the action is mentioned as push. Next, what it will do is like it will print this job is running on Ubuntu runner.os. So since we are running on the Ubuntu machine, it will print as Ubuntu hosted machine. Similar to that, it will print all like this one. And here you could see like here we are using the users. So users key name implies that we are using the other action. In this example, I am using the actions.checkout. So basically what this action does is it will clone the repository. So let's see how we can leverage the DevSecOps in GitHub action. In the first step, we are going to do SCA. SCA stands for Software Composition Analysis. In this phase, we will scan for all the dependency in our code. Recent security incidents shows that we should not only make sure the application is secure, we should also make sure the dependency that we are using in the application also is secure. So let's see the action. In this action, I'm just naming the action as SCA, and I'm telling the event trigger on every push request the job has to be done. Once it is done, I'm using the checkout action to clone the repository. Once I am cloned, I'm installing the tool called PyRider. So the PyRider is the tool that used for scanning the Python packages. Next time, after installing using the pip, next I'm scanning the requirement.txt folder where the all the packages is present. So this is how we can scan for source composition analysis. In the next step, we are doing SAST. SAST stands for Static Application Security Testing. In this testing, it is also a whiteboard testing because like we are scanning the source code of the repository. Here we will scan the source code for any security flaws. For this one, I am installing the Bandit tool, and after installing, I am again just scanning the whole application using the Bandit tool. So next we are performing the DAST scan. So for DAST scan, what I am doing is I am using the ZAP scan. So ZAP already provide the ZAP baseline scan. Basically, I am specifying I am using this Docker image to scan this target URL, and this is the rules that I have to follow. So in the last space of the DevSecOps, I am just scanning the container images. So for scanning the container images, I'm leveraging the Docker scan, which scans for any security flaws in the Docker images, and also I'm scanning the Docker file, using the add-on tool for any security flaws in the Docker files. So I also created a complete project on securing DevSecOps pipeline where I have written in detail about how to secure using the GitHub action, how to secure the CI/CD, and how we can do all the stuff in more detail. Yeah. So these are the reference material that you can go and share it and read it to know more about the GitHub actions and the DevSecOps. Yeah, I thank you everyone for listening to my talk. If I have any questions, I can take it now.
We're on mute. 1 second. Yeah, we're there. Now you can hear us. Thank you, Joshua, for your talk. That was great insights on how to use GitHub Actions and how to include your scanning in that. One question I have is, what do you prefer, to split your SCA, SAST, and all the other things into different actions, or combine them together into one action within GitHub Actions? What do you prefer personally?
I prefer personally splitting the actions into multiple files.
And
so
why?
The more decoupled is, so the more the less time it take. One thing is the less time it take. Other thing is like if you want to change anything, it is easy for to make sense.
Absolutely, I totally agree, and I think that's good. That's a good takeaway as well, as that it takes less time for each individual action to complete. So I think that's a great thing for everybody to take with them. Thanks again for your talk, and was great having you. So see you around.
Thank you. Yeah, thank you.
Thanks so much, Joshua.
Thank you so much.